Okay, here we go. Yeah, thank you very much for giving me the chance also to introducing our paper, which is a completely different context. It's about radiology and diagnostics. And I want to motivate my talk by bringing you into a scenario, in a healthcare scenario, which is actually on our daily plate. So imagine you have to go to the doctors, and then what happens is you have to do a checkup. And what can happen is that you, for example, are a patient that needs to get an MRI scan. And a scenario starts, which looks like, if we simplify it like this. So we have a radiologist, and he's gathering data, usually DICOM data, which is medical data, of course. And then he uses a desktop PC or a 2D screen to analyze this kind of data. And then, hopefully, you get the right treatment you deserve and you need. When we look at this process, we actually think that it may look like this, right? So there's a lot of risk on this plate. So we think, okay, a radiologist is having an ambient room, is a very cool situation, has some time to do this. And, of course, we want to give him the best possibility to do a right analysis. We looked into that, and what we realized is that it looks sometimes more like this. So we have a radiologist who has just very simple accessibility to some desktop or other PC desktop solutions. And what happens here, of course, is that you have a lot of different influences. Like, for example, you have light. It could be sunlight or artificial light. And this, of course, influences a lot of things. Like, for example, contrast when it comes to radiology is very important, since we sometimes they need to see very fine detail to make a diagnosis. And that, of course, changes when you have a lot of influencing factors. As well as what also changes is, of course, then you have to maybe change the desktop, your display, and so on, and it can also lead to bad posture for the radiologist. So that's what current research is actually already looking in, and we thought about, since, okay, we have these cool kind of technology, so we, of course, want to use this also maybe in this context and hope it makes sense, right? So we looked into this topic and then realized, okay, virtual reality is already, there are some implications, of course, that are very clear when it comes to this context that, for example, when we use a headset in virtual reality, we can disconnect the radiologist from the real world, which in this case is a good thing since he can focus on the actual task. We also have a lot of space that we can use, for sure. And we have a high degree of mobility. And last but not least, of course, we can also not just show 2D data, but 3D data, and do this with, in terms of stereoscopic vision, meaning that we can really visualize it on a high scale for these kind of diagnoses. But while we were looking into literature, we were also realizing that there is something missing. So people just saying, okay, there's a lot of potential and there are a lot of benefits why we should use virtual reality or any kind of augmented reality. But what about the interaction? So we need to give radiologists intuitive devices or systems so they can use it, because we know that still, even though we want it to be different, the awareness and acceptance of this kind of technology is still not as we actually imagine. So we defined a research question which is basically about, okay, how can we change that? How can we do that? And therefore, we want to see what kind of concepts are needed and how can we do that, and for also evaluate that it may be applicable for radiologists. Therefore, we designed a virtual environment and tried 3 different interaction concepts. The one is an indirect concept, then we have a indirect concept, and we developed a direct concept which is all based on the control symmetry of the devices, of the object, meaning how we actually can, or the radiologist can control such an environment. I will come to this in a minute, but first, how did we derive that? So, of course, we did not do just guess how this works, but we, methodology-wise, we did a first pre-study by asking 4 radiologists and also 9 UX experts, which have also a background in medical engineering, and we asked them, okay, what are the issues and how can we basically solve them? And what came to conclusion is that functionality-wise, it is very important for radiologists to do windowing and scrolling, meaning they have these slices of pictures of a specific area of your body, and then they want to scroll through it, which is very simple, so slice by slice. And what they also want to do is they want to do windowing, meaning that they want to change the contrast and also the brightness of the picture. Since we know that they are not using a lot of technology in their everyday life, or in their current life, or in their work life, we thought, okay, we tried a very minimalistic approach, and where we use gestures and leave out the controller interaction for itself. Therefore, we had a look, or we used the interaction fidelity model to design our different kind of interactions. And whereas the input veracity and the biomechanical symmetry stayed the same, so we used hand gestures and hand motions by using the leap motion device. We changed the control symmetry of how you can change objects from a very direct interaction towards an indirect direction, and evaluated this. I think all of you know that, so that's how the approach is going. So you use the leap motion, put it in front of your headset, and then you're able, by introducing infrared light and using an infrared camera, to exactly know the position of your hands. Right. Okay, so first of all, here you see the virtual environment we created. So we have a working desktop which is placed in the front, and then we have 2 different kind of screens which you used for a first trial. So meaning we have what the radiologists need is they need slices from 3 different perspectives. So meaning the coronal, the sagittal, and also the axial plane. And then they can use and diagnose and start doing what they want to do. So for selecting, we did a very simple approach, meaning that we just used the center field of view, and if somebody's looking towards a picture, then it's selected on the desktop, as you see here, and then in the next step, they are able to interact with it. For really interacting on this, we used a direct interaction, as we said before, where people can really start grabbing and using the desktop to change the individual parameters they want to, and then, for example, as you see here, scroll through the data set and do a very intense analysis. We also have a semi-direct approach where we use an object reference, like these bars, which is a very classical approach, and we also use an indirect approach where we use pinch gestures to give them the possibility to perform the same action. As I said before, we were very interested in how it is perceived by the radiologists, so we used we had 9 participants, which were 9 radiologists. They didn't have a lot of experience with virtual reality before, as we already knew, and they never used gesture interaction or hand interaction for it. We let them perform 3 different tasks in virtual reality, meaning they had to scroll through a data set and then do a diagnosis towards the kidney, the lungs, and the abdominal aorta. And of course, meanwhile, they were doing a think aloud, which gives us the possibility to observe how their experience was. Parameter-wise, we looked into the user experience and the usability of the system and the individual interaction concepts. And therefore, we could state that, I will come to this later, but we use the User Experience Questionnaire, which is a validated questionnaire to look into the attractiveness, meaning we wanted to see the pragmatic and hedonic quality of the device and therefore figure out what can be used best. And first I want to start with the usability. So in the pictures before, you've seen that we use this 3D model as a reference to give the radiologist the possibility to see where they are in their slide stack and what they can and where they can go depending on the plane they just selected. And they let us know that they are not really interested in that. So as you can see here on the evaluation or on the results, they don't need that. They say they are very good with actually using 2D slices of the data, so they would not use that anymore. What is very pleasing, though, is that they got the hand interaction seemed to be very intuitive for them, and also there weren't a lot of missing, so they felt very well in virtual reality. When we look at the selection task, then we see that there are overall very satisfying results, but what we see in terms of dependability is that we have still a lag there, and I think it's because we're using the approach of just using the center of field to select specific objects, but we will come to that in the discussion. And also when we look into the 3 different interaction concepts, like the direct, the semi-direct, and the indirect one, we can see that in terms of pragmatic quality, meaning perspicuity, efficiency, and also dependability, we have a tendency that the direct interaction with the object performed best, and we also see that the indirect interaction has a lag when it comes to dependability. So, in conclusion, I want to state that we actually find our approach very promising, so virtual reality should be a part of diagnosis since we have plenty of advantages. We explored 3 different interaction concepts for that, and we figured out that people really, or radiologists also, are really interested in having a direct interaction for that. For future work, as I said before, we want to implement not only we want to enhance the selection task, and therefore we want to implement gaze tracking to improve where, and that we always know where people are looking at. We actually want to redesign the 3D model because we think it's still important for the radiologists. They just are not used to work with that, so we have to give it another thought. And of course, we also want to enable out of field of view interaction, meaning one reason why the dependability when it comes to the indirect interaction was so low is that when people are not in the tracking area of the magic leap, of course, then no interaction could be performed. And we want to compare our results not by just looking at the user experience and the usability, but also do some hard measurements, meaning we want to do some performance measurements. With this, I want to close my talk and thank you, and I'm welcome to answer questions.
Thanks, Markus. Microphones are at the front. So you've created some new interaction techniques for diagnostic radiology. As you mentioned, it's sort of a very sensitive art where they have to have fine contrast.
Yeah.
Do you think, or did you notice any differences in their ability to accurately perceive different elements of the radiology based on their interaction technique? Do you think that impacts their ability to use it accurately?
So I think that's still a problem because especially when it comes to accuracy, it's very hard to go through the data set. So but we were very curious about this as well. So we did it we had some post-interview results about that. You can read that in the paper. But the radiologists were saying that it's already very good for them to deal with that. also using this early stage of prototype. So but we want to investigate into that. On the other hand, would have brought some more accuracy in this case would have been to use the controller, because then we use the HTC Vive for that, and then we would have known that the accuracy is higher. But it's not, when we are honest and we go to the application area, then we have to say, okay, that's not an approach, because they would not use it in the future.
Okay. I've got one other question.
Yes.
Another potential use of radiology is to explain to patients what is potentially wrong with them, or communicate their health, or something like that. Have you thought about the patient experience and the interactions in VR in that case?
We want to do this as a next step, because it's also related with cooperation. So a lot of radiologists let us know that they are very interested in just quickly sharing their results, and they can do it in 2D, but they would really appreciate, that's the topic about having a 3D model and working on it together. So that's what they haven't experienced before, and they would like to have it in the future.
Perfect. Let's thank Markus.